Good morning, guys. So, today we'll be starting a new chapter, which is determinant. So, yeah, let's start without wasting much time. The very first, determinants of second and third order. Dissemble this. Basically, order is same as we did study in matrices. You should know, I hope you know the difference between the determinants and the matrices. For the rules to are different in both the cases. Just the addition is same. Other things are different. Okay, so next part is this is called determinant of order 2 because it has 2 rows and 2 columns. And then you can find the value of the determinant basically. Determinant is about like to find the value you just have to multiply a1 into a2 minus a2 into b1. That's it. This is called the value of the determinant when you find out. Third, if it is third where 3 ordered determinant, the like matrices we used to have like 2 into 3, 4 into 6. You can have any order for the matrices, but for determinants it need to be square. The length and the rows and the columns, the number, it has to be same. This is the symbol to represent the value of determinant. Then to find this, like we will open it, you can open it through this column, through this row. It just depends on you. Suppose here they are opening with a11, they are opening with this row, right? So they have kept this there, a2 here, 1 2 a1 3 here, and if they have taken a1, then they cross things out like that. So they cross the row and the respective row and the column, and whatever the left is they write it here. For a2 they cross this one, and whatever we are left with they write it here. For the third one they left whatever they write it here. That's simple. But here it will be minus 1 into 1 plus 1. Here, are you understanding? Like if the 1 plus 1 is 2, and minus की power minus 1 की power 2 is always 1. 1 2 is 3, so 1 plus 2 is coming 3, so it will be minus here. Are you understanding why minus is there? If it is odd order, if the element you're taking is it at the odd position, the sum of the the index is odd, in that case it will be negative. 1 and 3, the sum is 4, so it's even, so it will come out 1, and then you solve it like you did in the first one, the same process, and then you'll get it. This is very simple. This is how we expand the third one. Similarly, we use the same thing to like 3 is the ultimate. We will not be studying more than 3 till class 12 in JEE, advance, or you are talking about international Olympiads. You will be studying 3 only, 3 order determinant, till 3 order determinant only. So minors and cofactors of determinants. So the how to find the minor, like you have taken this, then the one that here come here is called the minor of a11. For the minor of a22, when you cut test everything, whatever left is called the minor of a2. For a minor of a12 is this, minor of a11 is this, minor of a13 is this. That's what we are talking about. This I hope you understand what is minor now. Okay, and then here we had minus 1, considering minus 1, then we also consider this with the sign, then it's called cofactors. Minus with the sign is cofactor. Okay, and then we represent cofactor like this, minor like this with the sign m, and yeah, you can see. And now we solve it out. For the minor, you can solve minor, you can solve cofactor like that, and then you'll again find out. It's simple, quite simple. Next, notation or operations performed in the rows and columns of the determinant. Suppose the row I, where 1 2 3 j is this is representing, then you can interchange it. You can change interchange any row with anything. The answer will be same. If it is, suppose a is equals to a11, a12, a21, a22, if it is about this, sorry, I wrote it wrong, it is like this, 1 and 2. If you have this determinant and you have to find, like, you can add anything in the, like, do anything, like you can interchange this row by this row, it will be same. A11, A12, you're keeping this as the, now the column, this row as the column, and this column as the row. Simple. So these two are equal, you can make out very easily. The addition of m times the element of ith row, the corresponding jth row, is same. RJP, you can add any row, the answer will be same. That's what I'm saying. Okay, I hope you're getting it. So now we'll just, so the very next properties, these properties are very important, just try to learn them. Like in the we can addition it with the mrj, mrk, anything. That doesn't make sense, the answer will not change. Delta will remain same, that is the value of the determinant will remain same if you multiply the column or any row. On row you can multiply row only with any scalar rate. That doesn't make sense. Then the properties of the evaluation of the determinants. If you can change all the rows and the columns, like here E1 to 2 is here, B1 B2 here, C1 C2 is here, the columns are now the rows and the rows are now the columns. You can do it and it remains same, that's what I told. Then you can do, like, you can change this one here, this one here, and then you have to add one negative sign. One you can change, but you cannot change two. Like if you have done one transformation only, you've taken this from here to here, it's one transition, so you add minus. Like if you add two transition, then you add two minus, so it becomes positive. I hope you get it. Now the third one is this. The if elements of the same row are multiplied by a number, then the determinant becomes multiplied by the number. That's what A1, B1, it was remains same. Then if you multiply the row by any scalar, then it means you're multiplying the whole it by the determinant, basically in the scalar case. You can take m out of 3 or common in one row or either in column. It could also be written as A1, M, A2 if you are getting confused. This is also equal to this. If any two rows, any two columns are identical, a same, then the value of determinant is 0. It's a very nice property. Even if you solve it, then you will get it to know that it's always 0. When you will solve it, then you can even solve it to get that if any row, two rows are same, it becomes 0. So the value of the determinant does not change when any row is multiplied by a number of expression or is added or subtracted from any other rows. Okay, so if you add anything or subtract anything to any column or any row, then the determinant does not change. Its value does not change. Like here, we have added m1 c1, m1 c2, m. It's not getting difference. There is no difference. It's all equal. You can write this as this. I hope now you understand this also. You can write this as this. That's what it is saying. I'm writing it in this way. Since these two are ratio, the ratio these two are equal, so it will become 0. Let with this only. That's how this is equals to this. Simple. The same thing we are applying here. Here we are adding three terms. So alpha 1, beta 1 are being differentiated. So simple. So remarks, some important. The value of the determinant like this. If you are converting ri into ri plus mrj plus nrk, I told you that you can add anything, row and column, and multiply also with that row column with any number, scalar number basically. Then that will be same. The operation enables us to convert the maximum element in the results for making evaluation of the determinant simpler. So by using these methods, you can make your determinants into somewhat way which will be easier for you to maybe prove something, maybe to get something very important. So these are some properties which you can use and change to prove or to find out the solution of some important determinants. That's what it is. It's used in by using this property. It is very useful property. And if you put like there is some like here, and there was instead of it was something like ax, bx, cx. Okay, if it was, then in that case you put x is equals to 0, then the determinant was getting 0. So that means if we put x is equals to 0, that is 0 is the factor of that determinant. Okay, so that's what it is saying. If you put on putting the value of x anything, if you get 0, that means that is the solution or that is the factor of that determinant. Determinant which have like it's a diagonal determinant, you can know it is a, b, and only c. Now the next point. So if a, b, c, it's a diagonal determinant, and a, b, c, while solving it, it is always equal to ABC. If you will even solve it, you will get ABC. You can solve it using normal method also, still you will get the same thing. That's what I'm saying. Like here, if you have ABC or anything like this, still you get ABC. You can solve it. You will get this only. The determinant this is reflected along, like this is a skew symmetric. We studied that na in matrix. Don't confuse it by that. This is always equal to 0 in determinant. But its matrix was never 0. We never call that matrix 0. That is the difference between determinant and matrix. But in determinant we can find one value of that determinant, but in matrix we cannot. This matrix is just used to find solutions, is used to prove, is used to equate, multiply. You can do matrix, but that's why determinant is different. Here you just find its value. Okay, now determinant of cofactors. Suppose this was the determinant. I told you what is the value of cofactor a11, a12, cofactor of a13. So in that way, like a1 cofactor will become this plus this only, because negative 1 plus 1 is positive, so negative 1 will become positive, no sign change. That's what it is. So in the same way you can find, if you take cofactors of every one and you put and make a determinant, this is equals to delta square. The value of this was delta, then this becomes delta square. If delta was 0, then the determinant of its cofactor is also 0. That's what it is saying. This is basically the formula. It was 3 angle, that's why it was squared. But if you have 4, suppose it's you have get the determinant 4, suppose you get the 2, 4 we're not studying, but you can find it using this formula. For 3, for 2, suppose the determinant is something like this, then the determinant of it cofactors a11, a21, a12, this is equals to this determinant, n is what, 2, 2 minus 1, so it is equal to that determinant. I hope you can see. That's what it is saying. So this is a very nice property for the cofactors. So you don't have to find the cofactors. It's a square. Nice property, na? Now we are studying the product of two determinants. Suppose this is the one product determinant, this is the second determinant. Then the product of d1 and d2 is by using this formula. You just have to multiply the same I told you in the matrix. It's the same, bro, nothing difference. You just go through the, I hope you ever dive into the matrix chapter also. I already told you how to do the multiply of this. Like you are doing row wise multiply. I told you about the row wise multiply in matrix chapter also. Just go through that revision video. Since the value of determinant remains same when rows and columns are interchanged, therefore in finding product the two determinants can also multiply rows and columns by the columns by column. That is d12 is equals to d21. Commutative property is same. Now important observations we are seeing. So if suppose d1 is equals to this and d2 is equals to this, and ai is the cofactor of ai, a1, bi is the cofactor of bi, ci is the cofactor of this, then since it's a 3 degrees, so it becomes delta n minus 1, delta it's 3, so it becomes square. That's what it is saying. Now we will be talking about the area of the triangle. We can easily find the area of the triangle using determinants, where like these are x1, x2, x1, y1, x2, y2, x3, y3 are the vertices of the triangle. Then the area can be found using half. Doing half, and then you put x1, x2, x3, y1, y2, y3, and here 1, 1, 1, and then you solve it, you will get the area of that triangle. And area of parallelogram can also be obtained by using this. You just have to, whatever you have done half, you don't have to do half. If you cut this, then you will get the area of that parallelogram. Simple. Area cannot be positive, cannot be negative. At least here it cannot be. In physics it is possible, so don't get confused. In maths we are dealing with only like x-axis and y-axis, right? So whatever area we get in one plane, it's always considered positive, but area has direction. Okay, when you will solve in 3D, then area has direction, and negative and positive does matter. When you have time axis, like we studied in time, you have one more axis which is a time axis. In space time graph we study those. In that also the area you get the positive and the negative, so don't confuse it there. Yeah, that's what it is. So the magnitude here, it's since just 2D, so we will consider that the area is always positive. That's why you have mod over here. If it is 0, the area is coming out to be 0. That means the points are collinear. They lie on one line, so they don't have any. So these questions are very asked in boards. Prove that it's collinear. I hope you will be knowing because you have already studied, so you are doing just revision. That's why. A system of linear equations. Suppose these are the equations that you have. Solution. Otherwise, if these all the linear equations, we have linear equations 1, 2 like that. It's said to be consistent if it has at least one solution. Okay, so I hope you know what is consistent and what is inconsistent. We will study about it. What is consistent, you know, if there is one solution, and what is inconsistent, at least one solution. It can have 2, 3, it will still be called as consistent. But if it has no solution, it's called inconsistent. Now I'll be talking about the system of homogeneous equations in three variables. Suppose this is one equation, and this is the another equation. This is one equation, this is another equation, this is the third equation. Okay, so you have to find the solution. Basically, if x is y is equals to y is equals to z is equals to 0, we get a trivial. This is called a trivial solution. So system is always consistent. You put x is equals to 0, y is equals to 0, z is equals to 0. Every case they will be equal. That these three, all the three equations will be satisfied. So 0 is a solution of it, and hence it is consistent. There is a unique solution. If this is never equal to 0, there is a unique solution. This is called trivial solution. But if delta is equals to 0, the system has infinite number of solutions. Existence of non-trivial solution. If ever time you find the value of the determinant to be 0, that becomes infinite number of solutions. And if it is not equal to 0, suppose these are the equations, you have to find its solution. So you just put out this. If this is equals to 0, then it is non-trivial, and if it is not equal to 0, then there is a solution, there is a unique solution, and that is called trivial solution. 0, as we already solved using these equations, that 0 is the solution. Next is, so I hope these questions are directly asked whether it is trivial or not, so I hope you now know about it. So let's start with the Cramer's rule. So in Cramer's rule we have one equation, two equation, three equation. The denominator determinant is never equal to 0. In this case, the numerator determinant is this, and the numerator determinant of y is so the Cramer's rule. This is very easy since I've made a table for you. I hope you guys will understand. So Cramer's rule, you'll find the value of d first. You know how to find the value of d. So if d is not equal to 0, that means there will be a unique solution. And if d is equals to 0, then if at least d1, d2, d2, all three are not 0, no solution. If d1, d2, d3, if it is equals to 0, then they will have infinite solution. Like if d is equals to 0 and there are only one d that is equals to 0, other d's are not equal, in that case there will be no solution. And if all the d, whatever you put, in place of x, whatever you put, like all d1, d2, d3 is equals to 0, in that case there will be infinite solutions. So in case of no solution, you, whatever the equations were, I told you na, like three equations, you make out of these equations, you make a determinant. So in that case, even upon a to the ratio of all the coefficients are equal, but not the constant one. And in infinite solution, 1% case, planes are parallel. This is like if you have been asked like to prove that planes are parallel, then you can use this, like d is equals to 0, then d1, d2, d3, you have to find, like if you put this as this 0, then also this is equals to 0. That is the way that you prove that okay, this is parallel. I'll tell you of how to find d1 and d2 now. Suppose there were three equations. This, you find like d1 upon d is x. Simple, you just have to find a d1 upon d that is equals to x. This is d1, I hope you're getting it. d2 upon d, z is d3 upon d. I hope you're getting it. Now in d1, I'm telling you what is d1, d2 and d3. So d1 is how you get just d1, d2, 3 instead of a1, a2, a3 you put this. For d2, instead of b1, b2, v2 you put d1, d2, d3. In d3, instead of c1, c2, c3 you put d1, d2, d3. I hope now everything is clear. That's how you get whether it has no solution, it has infinite solution. So Cramer's rule is basically used to find number of solutions. It can be asked in the question, find the number of solutions of this determinant, then you use this formula. This is very nice way because questions are asked in J means, at least asked. Advanced though is like, yeah, even in advanced they can ask, but for sure means a lot of questions come from this topic. So yeah, I'm ending it now. Thanks. By the way, one thing I would like to tell you, like since we're talking about the axis and the area, so I wanted to ask you, like, what is this shape? See? And if you study this shape well, there are a lot of phenomena going on in space. like these. Right now there are a lot of theories based on this. Generally it says that the space is of like this, space is not straight and you don't know, it keeps on changing, it's moving. These are all the theories. So I hope you will go through and research on these topics. These topics are quite interesting. Yeah, so thank you, have a nice day.